This is Mom Bing. Welcome to my class. I know that you are eager to learn new things, and I am here to guide you.
Motion in one dimension.
Our universe is full of objects in motion. When you look into the sky in the morning, you can see moving objects across the sky like birds, airplanes, and clouds. Everything in our universe is in motion. Kinematics is the study of motion without considering its causes. It also involves describing motion through properties such as position, time, velocity, and acceleration. In today's lesson, we will understand the motion of an object in terms of distance or displacement, speed or velocity, and acceleration. To avoid confusion, our discussion will focus on the motion in one dimension. When we say one dimension, the direction of the moving object is just up and down, or back and forth, sometimes north to south, or east to west, or vice versa. Are you ready? Now, let us start.
In this video, we're going to talk about the difference between distance and displacement. If this car moved from point A to point B, we could say it traveled a total distance of 100 meters. Distance is a measurement of the length between 2 points. Now let's go back to this example and add another road sign here. Let's bring this one in so we have a direction. Now if the car again traveled from point A to point B, we could say that it traveled a distance of 100 meters, but we can add in another part of this measurement. We could say it traveled 100 meters to the east. And this is actually a displacement rather than a distance. The difference is that we're including a direction this time around. Now the definition for displacement is the overall change in position. So we're looking at a starting position comparing it to a finishing position. And then the other big difference here is that displacement is going to include a direction. Now displacement includes a direction, and so we call this measurement a vector, and so measurements that include directions are called vectors. Distance doesn't include a direction, and so it's called a scalar. Let's add another road sign here in our example. So if we add this extra midpoint here road sign, it'll bring our car back to the point A, and if the car travels from point A to point B and then just backs up here to the center here, let's see how far it traveled. Now it's traveled a distance there from point A to point B of 100 meters, and then it traveled an additional 50 meters for a total distance of 150 meters. Now if we look at its displacement, however, we're comparing its starting position, which was right here, to its finishing position, which is right here. And so its total displacement would be 50 meters to the east. In other words, it's 50 meters east of where it started, which was right here. Let's look at another example here. If you've ever run track and field, you may have had the chance to run the 400-meter race. The 400-meter race is one lap around the track, and for a total distance of 400 meters. Now, what would the displacement be? Well, if we compare your starting position right here to your ending position right here, we would say that your total displacement was 0 meters. And it's almost like if you were running the race and all the fans just shut their eyes as soon as the gun went off and then opened them again when it was all over, and it looks like you're in the exact same location. Your displacement is 0.
Now let us summarize distance versus displacement. When we say distance, it is the length or path between the initial and final position of the object. It can be expressed as distance is equal to initial position plus final position. So D is equal to di plus df. So this is the formula for the distance. For the displacement, It is the net change in position of an object. It can be expressed as displacement is equal to final position minus initial position. So the formula is displacement is equal to df minus do. The triangle means delta. It is a Greek word which means change, so change in position. df means final position, and do is the origin or the initial position. Okay, now you are ready for the computation. Let us try to compute the problem about distance and displacement. Okay, we can see that there are formula at the top of this screen. So this is for the distance and this is for the displacement. All right, let us calculate. So this is the sample problem. An athlete jogs 2 kilometers heading south and then moves 1 kilometer north. Compute for A, distance, and B, for displacement. All right, so first, of course, what you will do is to analyze the problem. So what are the given data? Here given we have 2 kilometers, and this is the initial position, and of course we have here 1 kilometer, that is the final position. For the formula number 1, or for the missing data, we will look for the distance. So solution, of course, we will use d is equal to di plus df. All right, initial position 2 kilometer plus 1 kilometer, so add total distance is equal to 3 kilometers. So this is the total distance covered by the athlete. Now for displacement. All right, again, analyze the problem. Of course, look at the difference. Although there are some similarities on the given data, but the direction is indicated when it comes to displacement. So given 2 kilometer south. All right, this is south, that is the initial position, and 1 kilometer to the north, and that is the final position. All right, so we are going to compute for the displacement. Of course, we are going to use this formula for the displacement. Change in position is equal to df minus do. All right, 2 kilometers south minus 1 kilometer north. So the displacement or change in position is equal to 1 kilometer south. All right, so this is the displacement and this is the distance.
Thanks for stopping by. I'm Virgil Ricks and this is 2 Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's clear up a few things right off the bat. First of all, speed and velocity are different. And acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second, these are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration. Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? Alright, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. So whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is so cool.
So now let us try to compute and compare for the speed and velocity. When we say speed, the formula to be used is S is equal to d over t for distance over time, and velocity is equal to displacement divided by time, or v is equal to displacement over time. Okay, this is the sample problem. A tricycle toward east covers a distance of 15 km in 45 minutes. Find its speed and velocity. For the speed, of course, we will use S is equal to d over t. So given data, we have 15 km, that is the distance, and 45 minutes, that is the time. Okay, S is equal to distance divided by time. So distance is 15 kilometers divided by 45 minutes is equal to 0.33 kilometer per minute. So that is the speed. For the velocity, of course, here the difference between the two is, of course, there is again direction. Okay, so given displacement, of course, 15 kilometer east, and the time is 45 minutes. Missing velocity, v is equal to displacement divided by time, 15 kilometer east divided by 45 minutes. So the velocity is 0.33 kilometer per minute to the east. Alright, ayan. So the difference between the two is the direction. And then for the acceleration, when we say acceleration, it is the rate of change of velocity over change in time. Formula: acceleration is equal to change of velocity divided by time, or A is equal to change in velocity divided by change in time. So where delta V is equal to final velocity minus initial velocity, and delta time is equal to final time minus initial time. So let us compute. A truck initially moves at 20 meter per second, then accelerates to 50 meter per second in 6 seconds. So what is the acceleration of the truck? Given Vf is equal to 50 meter per second, and then initial velocity 20 meter per second, and time 6 seconds. Missing acceleration solution, so we are going to use this formula for the acceleration. 50 meter per second minus 20 meter per second divided by 6 seconds. So 30 meter per second divided by 6 seconds, acceleration is equal to 5 meter per second squared. Okay.
That's all for today, class. Thank you for listening. Bye. See you next time.